Right, we're going to start our chapter 10. Chapter 10 is on areas. Pretty straightforward, but let's just dive into it. Let's start with things that we're very familiar with. The area of a square is base times height, or a side squared. And the area of a rectangle is base times height. You probably know the area of a parallelogram, but I want to talk about why the area of a parallelogram is what it is. And I believe I've shown this in class, but it's worth discussing a couple of times. Here's a parallelogram. Its base is 10 inches, its height is 4 inches. It's tough to tell what its area is just by looking at the shape in this way. But if I thought about taking this triangle right here and cutting it out, I'm going to draw it a little bit sharper. Taking this triangle right here and cutting it out and moving it over here. So we have to imagine now, like, this side is gone. Well, we've formed a rectangle, haven't we? This is going to be a right angle. This height of 4 will match this height of 4. This length was 10 to begin with, because with a parallelogram, remember, on a parallelogram, all sides are congruent. So if this is 10, then this is also 10. And this bottom length didn't actually change, because the length that was over here just got moved over here. So it's actually a rectangle with an area of 40 square inches. So the area of a parallelogram is the same as the area of a rectangle because it's base times height. Come on, work with me. The area of a rectangle is base times height. So, if you can, please find the area of this rectangle. Pause and do that. This 12 right here is not the height. Okay, the height is a perpendicular line that goes from one vertex to the opposite side. So we need to find that height. Well, here's what I do know. I know that this length here is 12. I want to find this height here. If I think about that tiny little triangle, if it's a right triangle, I can run Pythag. I know 2 squared plus b squared is 12 squared, which means that 4 plus b squared is 144, which means that b squared is 140, which means that b is the square root of 140, whatever that is. And I was calling it b just because in a right triangle you use a, b, and c. But that's really h. So the height of this triangle is square root of 140. So now we know that the area, which is base times height, is 6 times the square root of 140, which I could calculate that decimal or simplify that radical if I cared to. I just don't really care to. But it looks like I'm going to anyway. 6 times the square root of 140, 71. 71 units squared. Sick. There's parallelograms. I also want to talk about why the area of a triangle is what it is. This is something else that I'm pretty sure we've done in class. But you know that the area of a triangle is 1/2 times the base times the height. It looks better when it's written like this. Or I think this is also real classy. Area is 1/2 base times height. Again, let's talk about why. I'm going to take a copy of this triangle and rotate it 180 degrees. When I put it back on, it forms a parallelogram. All these sides are parallel. All these angles are congruent. The sides are congruent. So this length matches this length. This length matches this length. This length matches this length. It's a parallelogram. A triangle is 1/2 of a parallelogram. So the area of a triangle is just 1/2 the area of a parallelogram because a triangle is 1/2 of a parallelogram. We're going to use that same sort of idea to find the area of a trapezoid. Now a trapezoid is a quadrilateral with exactly one pair of parallel sides. So the two bases are the parallel sides. Here's base 1, here's base 2. The bases are parallel. The other two sides are not. The legs. This is called a leg, and this is called leg. The legs can be congruent. In this shape it looks like they are, but they don't have to be congruent. How would you find the area of a trapezoid? Well, one common place to start thinking is like, okay, I can make two triangles. And so if I can find the area of this rectangle, then these two triangles, and put all that together, then I have the area of the trapezoid. The problem with doing that is when we made these little cuts here, you know, like we have this cut right here for the height, we don't know this length. And if we don't have any information about the trapezoid, we can't find that length. So that can be a very tough way to do this. Here's a better way. I'm again going to copy this trapezoid. I'm going to again rotate it 180 degrees and slap it on over here. Well, this length of B1 is now up here, and this length of B2 is now down here. We know that these two sides are the same because they're literally the same. They copied from each other. We now have a parallelogram. So let's first just find the area of the big parallelogram, the area of this parallelogram. The area of that parallelogram is going to be the base, which is B1 plus B2 times the height. Well, the area of a trapezoid is going to be half of that, because right now we have two trapezoids put together. So the area of a trapezoid is 1/2 times the two bases added together times the height. One way you could think of that is this is the average of the two bases times the height. So I'll write that again. Area of a trapezoid is 1/2 times B1 plus B2 times height. Will you please pause and find the areas of these two trapezoids? This first one's pretty straightforward. It's 1/2 times 33 plus 17 times 8, which is 1/2 times 50 times 8, which is 25 times 8, which I think is 200. So it's 200 square units. Area always has square units. Perimeter has regular units. Volume has units cubed. This one, look how annoying I am. We don't know this height, but we know this is a right triangle. So we can find its height using trig. Here's the opposite. Here's the adjacent. I'm going to use tangent. The tangent of 35 equals h over 8. So h equals 8 times the tangent of 35. My calculator doesn't like to turn on sometimes. I'm going to make sure that I am in degrees. I am not. Ooh, close one. But sure, my calculator's in degrees. 8 times the tangent of 35 is 5.6. So this height right here is 5.6 feet. Oh man, but there's more frustrating things. Like, I don't know how high this is, how long that is up there. The fact that this is an isosceles trapezoid means that these two angles are the same. This is also 35 degrees. And that means that these two legs are the same. And that also means that this length right here is 8, because it's going to match this length over here. So I'm going to erase a bunch of stuff to try to talk about this real clearly for a second. Right now, the bottom length in total is 48. Okay, we have 8 here, we have 40 here. So the bottom length in total is 48. But I'm going to determine, if I draw this height, this length right here is 8. If that is 8, then this must be 32. I have to take 8 away from the 40 to make it 32. So this length right here is 32, which means this length up here is also 32. So my bottom base is 32 plus 8 plus 8, which is 48. My top base is 32, and my height is 5.6. It's not negative 5.6, just 5.6. So the area of this trapezoid is going to be 1/2 times 32 plus 48 times 5.6. (224 units squared, feet squared actually. If what I just did seems confusing, maybe pause and watch it again. But I found that since this was 8, this was 8, this whole thing right here, this part right here, was 40. So if this was 8, this must be 32. We have 2 more shapes to discuss. You probably think of a rhombus as a diamond. Okay, you see a shape like this, and you think, oh, that's a diamond. But a diamond is really a rhombus. It's any shape where all 4 sides are the same length. So a square is a rhombus. Also, a rhombus is a parallelogram. All the properties of parallelograms apply to rhombuses. So one way you could find the area of a rhombus is base times height. But here's another way. These diagonals, they bisect each other, so these 2 lengths are the same, and these 2 lengths are the same. They also always bisect each other at right angles, which is kind of crazy. We can use the diagonals to find the area just as well as we could use the sides. So let's find the area of one of these trapezoids. This right here, I'm going to call D1, diagonal 1. And this right here, I'm going to call D2, diagonal 2. I want to look at the area of one of these big triangles. So I'm going to look at this triangle right here. I'm going to draw it over here just so it looks a little bit cleaner. It's basically this triangle. Well, the length of the base is D1. The length of the height right here is half of D2. Do you see that? This right here is just half of this. So the area of this first orange triangle, and I can't stress enough, remember there's 2 of these. So when we find one, we found the other. But the area of this triangle is 1/2 times the base times the height. But the base we're calling D1, and the height is half of D2. So that's altogether 1/4 of D1 times D2. That's the area of this triangle right here. To find the area of the whole entire rhombus, we have to remember there are 2 of these triangles. So 2 times 1/4 is 1/2, so it's 1/2 times D1, D2. The area of a rhombus is 1/2 times D1 times D2, which is the 2 diagonals. So multiply the 2 diagonals, cut them in half, you have the area of your rhombus. Because the rhombus is just 2 triangles, 2 congruent triangles put together. Okay, our last shape is a kite. A kite is a quadrilateral with 2 adjacent pairs of congruent sides. So what that means is these 2 sides are congruent and these 2 sides are congruent, but they're not opposite each other. They're adjacent, they're touching each other. So we don't have a parallelogram. The diagonals intersect at right angles, and one set of diagonals, the short diagonal, is bisected. So the 2 sides are congruent. This length here is the same as this length here. We're again going to find the area of this shape, thinking about triangles. Here's a big old triangle. And that triangle is half of the kite. So once I find the area of the triangle, if I just double it, I've got the area of the kite. Well, we'll call this D1. There's that diagonal. This right here we know is half of D2, because these two lengths are the same. So this length right here is a half of D2. Multiply that together, we're going to have the same situation we had last time, because the area of a triangle is base times height divided by 2. So I'm going to take all this and multiply it by a half. I'll write that better. It's a half times base times height, which means it's a half times D1 times a half of D2. That's again a quarter of D1, D2. That's the area of the triangle. The area of this triangle right here is a quarter of D1 times D2. Well, then the area of the kite is 2 of those. So it's 2 times a quarter of D1, D2, which is again a half times D1, D2. So the area of a kite is the same as the area of a rhombus. They're both a half times the 2 diagonals multiplied. A better way of saying that is a half of the product of the 2 diagonals. Okay, that's all of our areas for today. Parallelogram is base times height. Trapezoid is 0.5 times b1 plus b2 times the height. A kite and a rhombus are 0.5 d1, d2. Although remember, a rhombus could also be just base times height if you have those, because a rhombus is a parallelogram. Doesn't work for kites, but does for rhombuses. Nice work, everybody. See you next time.